3, 4. Hi, welcome to C# Programming on .NET. My name is Brett Robley, and I teach at Cal State University Fullerton. The class is ISDS 309, and in a previous video lecture, we wrote a program to create the names.txt file. Now we're going to go ahead and take a look at this file. It's a text file, but the author wants to use fixed width fields. So all of these fields are 10 characters. The shorter names have spaces padded on the right to get them to be 10 lines. But notice the file length is 70. And of course, if you divide 70 by 6 lines, you end up with more than 10. And if you add another line, here I'm adding 10 question marks and saving it, and then we go to the operating system and notice the byte length now is 82. So we type a line of 10 characters, we actually get 12 more characters at the operating system level. This is accounted for by the 2-character line terminator, the carriage return line feed that Windows puts at the end of every text line when you hit the enter key. Okay, so now let's go ahead and start a project to create a program that will access these names by entering a record number. So we'll call this AccessSomeNames to match what the author did in the textbook. This program or example program is also very susceptible to crashing, so I've changed some of the code or added some code to do some basic error checking using triparse so that we don't crash the program. Okay, so I put in the using statements. I'm also going to leave the namespace statement for now because I want to show you at the end of this video a way to delete the namespace and then reformat the code very, very quickly in case you don't want the namespace in there. Okay, so I'm setting up the file name here as a string. I'm going to do the normal routine here where we instantiate a file stream object and then wrap it in a stream reader object, which we've done in pretty much every video in chapter 14. Now we'll set up a integer end so that the user can signal when they're done typing at the keyboard. We did that in a prior program. We are going to declare a count variable and set it to 0. We will use this to track the number of records that we count in the file. We're going to define a num integer, which is going to point to the records in our file. So as we go through the file, we'll be updating num to point to which record we're at. And we'll also use this to seek into the file. Size is going to be how we calculate the line length. And in my comment here, I put erroneous in parentheses because the size of the file on the disk includes an extra 2 characters per line for the carriage return line feed line termination sequence. These are invisible characters that you can't see, so our size calculation gets a little bit funny. This is not typically how we would do this in industry. We wouldn't typically use a text file in combination with fixed field widths, but I suppose there's probably files out there that do follow that, and maybe this is an okay approach. But I'm covering it since it's covered in chapter 14. So we'll do a priming read now from the file. And I'm going to just write out the length of the first record that we read so you can see it does come out to 10. even though there were 12 characters on that first line. So the read line is throwing away the carriage return line feed. Next, we'll enter the while loop and we will test to see if name was null. If it was, then we have a file name, a file in the file system that's actually empty. We'll bump the count to keep track of the number of records in our file. So basically the whole point of this while loop is to run through the whole file and build up that count, or determine the number of records in the file. Now we're going to do the next read, and we'll just loop through until we get to the end of the file, and then we'll have our count set appropriately. Now, once we know how many lines there are, we're going to calculate using file.length and divided by the number of records or lines we just counted, and that's going to give the average line length to size, which is going to be something greater than 10. So now we will ask the user to enter the record number they want to start with for displaying the file, so they don't have to display the whole file. They can just display from that record on. We will then read the keyboard input from the user and store it in string S. Now, on this line, I'm going to put a one-line while statement together so that we can loop through and test what the user inputs until we get an integer. So I'm using try-parse. I'm feeding try-parse what the user typed and that we stored in S, and then it's returning the number or numeric version of that string into the num variable. Out means that we're passing a reference to try-parse, so it's really going to update num that we defined up there on line 16. And then we're going to test num to see if it's equal to end, and if it is, then we want to break out of this loop, and that would happen automatically because of the while test. And then inside the loop, we're going to do some additional checking. What if the user puts in a 0 or a -1? We don't have a record 0 or record -1. And so we're going to test to make sure that num is set to at least 1 if the user types something less than 1. And then if that's not the case, then we're going to test num to see if it's greater than the number of records we counted, and we will force num to be no greater than the maximum number of records we counted. Now only the if statements, neither of them may be true, but if one of them is true, only one of them is true. It's not ever the case where both of them would be true at the same time. Now we're going to use the fileseek method, and we're going to move the file pointer, which is currently pointing at the first character of the file. We're going to move it to past any records that the user doesn't want to see. So for instance, if the user typed 5, then we want to seek to the 5th line. And that's what this calculation is trying to give us. The problem is num minus 1 times size, where size is greater than 10, means that we're eventually going to be seeking to the wrong position in the file, and things will start to display funky. It doesn't happen if the file is really short like the one we're using, but if we had a larger file with many lines, this would not work in every case. So this is really not the best example. And then we'll print out a message saying, okay, we're starting at record 5 if the user actually typed a 5. Then we'll do a priming read prior to a loop. I'm putting lots of comments in this time so that it's easier to follow as you're learning the code. Now remember, on line 40, we told the file stream object to seek to a certain position in the file. So that means on line 42, when we actually read line, we're not reading the first line unless the user typed a 1. If they typed a 2, we're starting at the second line. Now we'll output a space plus whatever the contents of name is, and we're checking now if name is null, meaning it's at the end of the file. And then we'll continue to read lines from the file and output them to the display so that the user can actually see the information they've asked for. Now I'm going to add a do loop here. And remember, this is inside of a larger loop that ends on line, I want to say 53. And basically we've displayed the records per the user's request, and now we're going to ask the user to enter another record number in case they want to look at more records. We will then get the user's keyboard input telling us which record number, and then we'll test it again using try parse. Now I put the not operator in there to invert the Boolean return from try parse. Try parse is going to be fed the string, and if it can convert it to a number, it's going to store it in num. And now let's give it a try. Okay, see if we have any problems with the code. All right, let's enter 1, and it prints all the records. Let's enter 2, and notice it didn't print the first line. Enter a 3, it's now didn't, I'm just stepping through, as you can see, and then I'm going back down. And if I go too high, it just prints the last one because it forces it down. Now I'm going backwards, and now I'll print some garbage that would normally crash the program if we did it just like the book. And there's a negative number, and you see it sets it to 1. There's a big number, and here's a huge number, and you see it just doesn't do anything because we're basically using try parse to filter out a lot of this. Now I want to change the class from program to AccessSomeNames, and I'm going to delete the namespace lines 5 and 6. And way down at the bottom, I'm going to delete the last curly brace because I don't want to use the namespace. Now you might be saying, okay, that's great, but now everything's indented. How do we easily reformat this code? So watch this. Edit, go to Advanced, go all the way to the top, and format the document, and watch what happens to the code. Everything shifts over. You got nice lined up curly braces.